Right. Good evening, everyone. Online students, can you hear me? Okay, tell me. As part of HashMap, our target is stop storing duplicate objects. Number two, finding the added object by using new object. This is the story. Further, what we should do? We must override hash code method by returning which property? Common value property. By using, we want to group objects. Second, also we must override equals method by comparing the common value property and unique value property. Two things you have to compare. First point, hash code is always called on the adding object for finding its bucket. If not available, for creating the new bucket. Next, double equal to operator and equals method are used for comparing this newly adding object with already added objects available in entire collection in this bucket. In this objects hash code bucket. Very important. Double equal to operator and equals method are called only if this adding object hash code bucket is available. If not available, not called. Okay, now? Last 2 points. Now I'm going to talk. Before that, first point I'm talking. Conclusion points. Point number 1. You told me we must override hash code and equals methods in the adding object class. We must override hash code and equals methods in the adding object class for stop storing duplicates and for finding objects based on the data. If you are overriding, there is a contract. The contract between hash code and equals methods. Generally, people say hash code equals methods are lovers. You cannot separate them. Okay? General people call hash code and equals methods are lovers. Tell me, between lovers, there is a contract agreement. No? If agreement is not fulfilled, then break up. So same problem here. Not only between lovers, wife and husband also, there is a contract. If contract is not fulfilled, then divorce. So wherever hash code method is there equals method is there. Wherever equals method is there hash code method is there. Both must be overridden. If not overridden, useless. Already I've seen in the test case program. Okay. What is the contract? I will prepare the statement. You tell me, you understand that statement. If equals method returns true by comparing two objects, their hash code must be same. ఇది కాంట్రాక్ట్. ఏమర్థం చెప్పు. Why this contract? Okay, the contract in overriding hash code and equals method. You should not override as you like. There is a contract. What is the contract? While overriding hash code equals method, you must check it. If equals method returns true by comparing two objects, their hash code must be same. Yenduku. Why this contract should satisfy? Why this contract? Why hash code must be same? If hash code is different, what is the problem? If you use your brain, same or different, why? Okay, na? If you don't use your brain, just you present your body, then you'll feel same or different. If you use your brain, where hash code equals methods are used? With bucket. Right? If equals method returns true by comparing two objects, means these two objects belongs to same bucket and hash code must be. Understand the contract? Okay. I will ask the same question in another way. Second point, second contract. Actually, everybody is talking, this is only the one point, but H can't extra na. Right? That's why extra point. Because as an interviewer, I never ask regular questions. I will always ask around questions. The main point around I will ask. You will prepare and come to the interview by studying frequently asked question. I will ask the questions which are around that frequently asked. There you will be caught. That's why generally I'll cover not only main point, other points also. Let me see, will you understand or not? If equals method returns false by comparing two objects, their hash code must be dash. Same, different, maybe same, maybe different. Must be same, must be different, can be same, can be different. Don't use your brain, bring the bucket. Equals may returns false. False means both objects are same or different. Different bucket, different objects. Different objects can be stored in the same bucket or can be stored in the different bucket. Now I am giving statement. For example, I have taken double quotes A and 97. Double quotes A 97, if we compare equals returns what? False. False means they belongs to different bucket or same bucket? Same bucket. Because hash code is same, belongs to same bucket. Now, I am taking double quotes A, double quotes B. Double quotes A, double quotes B, compare by using equals returns what? False. And they belongs to what? Two different bucket. When equals method returns false, then their hash code may be same or different. Because they may belongs to same bucket or may belongs to different bucket. Algorithm understand? Then reverse question I am asking. Third, if hash code of two objects is same, okay? Now, if the hash code of two objects same, then equals method must return what? True na, false, maybe true, maybe false. Wonderful, super. Amayama na jeevitam dhanyamaindra. Okay, now my life is fulfilled. last 3 days of my struggle, finally you give me confidence that you understood. If hash code of the two objects same, it may be added in the same bucket or may not be added. If true, not added. If false, added. Equals method may return true or false. Now all the people answer. You able to give this correct answer because of my talent or because of your talent? Huh? Our talent. Thanks, Ro. Really, I'm saying it is because of our talent, not my talent, not your talent, our talent. I explained. You studied, practiced, understood, then come back. That's why you are able to give the statements. Right? If you don't study, how much efforts I am putting, it's waste. Okay, na? That's why I always saying, your success is our success. Your failure is my failure. Really. Your failure is not your failure, it's my failure. Success is our success. We can celebrate together. Failure, only I will cry. You will never cry because you will find some other path to get the job. But next batch students will come only by seeing your success. Correct my point? That's why please study well, study hard. Now tell me. Next statement, you only prepare. Fourth statement, sorry. If a hash code of two objects is different, then equals method. Different bucket objects are same objects are different objects are different objects. Different objects means must return, not may return. Must return what? False. These are the four statements. If you fulfill these four statements, then you have developed correct algorithm. Sir, how can I test are these four contracts are satisfied or not? Very simple. You no need to do anything. For satisfying above contract, override. Okay. For satisfying above contract. Very simple. What? Override hash code method by returning common value property. Override equals method by comparing the common value and unique value. That means in a hash code method and equals method, we must use same property. Common property you must use so that automatically above contract will be satisfied. Is it clear, online students? Please write down these points. The contract in overriding hash code and equals methods. If you write, you will understand, right? Just how to confirm, just I am writing the points. Scroll down. Completed? Okay. Now I want to ask a question. Please try to understand. Completed? Still writing. For example, in student class, from hash code, I should return course. From employee class, I should return department. From bank account class, we should return IFSC or branch or bank name, anything. Okay. Common property you should return. Okay. Now I am going to understand internal memory diagram. Up to now, I didn't explain the actual memory diagram. Imaginary memory diagram I have explained. Internal memory diagram. Hash map internal memory diagram. Understand. Point number 1. Hash map internal data structure is what? Hash table. Second, hash table data structure internal uses bucket. Okay. Hash table internal uses bucket data structure. Now the question is, how can we create hash table data structure? Data structure is nothing but memory. Okay, na? Hash table data structure memory. How can I create? Then next question number 2. How can we create bucket data structure? Okay, how can I create bucket data structure? Or else, what is hash table internally? What is bucket internally? Observe, hash table is nothing but an array. Everything is what? Array. Okay, hash table is nothing but array with 16 locations. Which array? Hash table is nothing but an array. Which array? What the type of the array? Object array, na? Array list class, vector class, internal uses array of what type? Object array. Then this array is what type array? Is it object array, na? Think. Is it object array? Think. Think. This is my, what do you call? Hash map. Inside hash map, now the array is created. I'm taking vertical because table na. With how many locations? 16 locations. Online students, 0 to 16. 16 or 15 or 50. Then what is this array? I'll tell you. Next point. Inside a hash table for storing objects, are you storing each object in one location? Objects as a bucket? Then what is bucket? Bucket is nothing but a collection. Collection of objects, a group of objects is what? Collection. A collection internally contains what? Data structure. What is the data structure? That is nothing but linked list. Oi, class linked list, no. Data structure linked list. Tell me, what is the data structure linked list? Linked list data structure will maintain objects by using. Come on, recollect. Ask your brain. Node, next node, next node, next node, next node. First node pointing to second node. Second node pointing to third node. Third node pointing to fourth node. Fourth node pointing to fifth node. This is which linked list? Single linked list. All this single linked list, all nodes is technically called what? Bucket. So ఒకసారి పెట్టి చూద్దాం. Tell me, all these linked list is technically called what? Bucket. Okay. All these linked lists are technically called what? Bucket. So tell me, our first node, nothing but first entry. Entry into what? Key comma value. Where key comma value should store? In this first node. To store key comma value in this node class. What is this? Class node, open bracket, closed bracket. Remember, linked list class, node class internally contain previous, item, next three variables. Na? In this hash table data structure, node class contain four variables. Number one, hash for storing hash code. Number two, next for storing next node. Third, key. Number four, value. So totally how many variables are there? Four variables. Hash is what type? Int. Next is what type? Node. Next node should store na. Key is what type? Object. Value is what type? Object. Then here hash variable, next variable, key variable, value variable. Key variable contain our key object A. Value variable contain our value 1. Understand? Understood? Right? Repeat once again. What is hash table? Hash table is an array object. Which array? Object array na, node array na? In these locations, what you want to store? Node. Then what is this array? Node. With how many locations? 16 locations. Okay? Now, let me write again the diagram. What is the bucket? Bucket is a single linked list data structure. So what is this? Hash table is nothing but node array object. Or you can say node class array object or node array object. Okay? Node array object with a 16 location. Bucket is a single linked list. Inside this bucket, for storing same key comma value, same hash code, key comma value pair. In this bucket, the same hash code key comma value pair is stored. The multiple same hash code key comma pair entries are stored. Okay na? Now tell me. Now where this bucket is stored? Finally, the bucket is stored inside this node array object. Node array object in one location. Which location? 0 na, 1 na, 2 na, 3 na? Where bucket is identified by index number, bucket is identified by the hash code number. What is the hash code number of double quote say? 97. That means in which location of node array the bucket should store? 97 location. Hey, what is the number of locations available in node array? 16. But 97 from where it is come? Now, first point, question number 1. How can we create, how the hash table object is created? Or you can say, let's say, what is? What is hash table data structure, or how hash table data structure is implemented? Okay. Next, what is bucket, or how bucket data structure is implemented? 2 questions answers I give it. Answer number 1, hash table is nothing but node array object with 16 locations. Answer number 2, bucket is a single linked list, and the single linked list will be stored in a one location. Now the question number 3. Question number 3. In which location the bucket is stored? In which location the bucket is stored? It's depending on hash code. Okay. How the location is found with the hash code? There is a formula. The formula for finding the index of this bucket is key dot hash code divided by hash map dot capacity. Okay. What is that? Key hash code mod. What is the meaning of mod? Is it return quotient or reminder? Reminder. The reminder value is the index of this bucket in this table. Okay, clear? Now let's try to apply this point. Tell me now, here what happened? Let me write the diagram. This is my hash table. This is my hash table. Whenever I create a hash map object, must article rat, cat, everything coming into the class and going. They are playing like over. What is this? Node array. Node array with what? How many locations? 16 locations. This is 0. This is 1, 2, 3, 4, 5, 6. Like that. Dash, 15. 0, 1, 2, 3, 4, 5, 6. Okay. Then now I am writing hm dot put of double quotes a comma 1. Then put method internally calls, assuming double quotes is a key one, k1 key 1 dot hash code. Hash code method is overridden in string class, returns 97. With the hash code number, bucket is created. Inside bucket hash value what? 97. But that 97 bucket should store in one of the locations in the table na? But number of locations, how many indexes? 16. 97 index is not there. We will get array index out of bounds exception. To bring this 97 to the range of 16, it divided by 16. 97 divided by 16, remainder is what? 1. If you want, you can do calculation. Okay, na? 97 mod 16 remainder is 1. Then remainder 1 you will get. That means this object should store in which location? One location. Inside the code will be like this. If what is this object name? Table. This array object name is table. Table of what the hash code number? Index I equal to null. Tell me by default all the locations are filled with what? Null. Null. Then what happened? Directly now table of I equal to new. What object is created? Node object. New node of by passing key value, value, hash value, and next value. So that initialization will be done internally. Then tell me now, background what happened? Here, node object is created with reference what? 1010 or 2020, whatever. First, what value? Hash. Hash value is what? 97. Then next, key value. What the key value? 111. Next, value. What the value? 1111. Assume like that, okay? I cannot find the number of numbers. And then next one is what? Next. Next variable value by default what? Null. And then key object contain A and value object contain 1 and 1010 store in which location? 1. So the moment this location is filled, that means what happened? One bucket is created. Na? What the hash code number of this bucket? 97. Understand internal implementation, code implementation? Then next tell me. If I write hm dot put of double quotes b comma 2, below what happened? Assume that is key 2 dot again called what? Hash code. Then equal to what is coming? 98. Now to bring this hash code to the index number divided by capacity 16, and then what is coming? 2. Hash code number is 2. Then what happened? In hash code number 2, any bucket is available? No. Then another new bucket is created. In this bucket, now the node is created with the same value hash with value what? 98 and the key B object value 2. Then next value null. And this 2020 will store in second location and point. Okay, clear? You must explain this formula and this diagram to the interviewer. If you ask, explain hash map internals. Your old students has explained both diagrams. Bucket diagram. Interviewer will easily understand the bucket diagram. If I have explained this diagram directly without the bucket diagram, the contract to that all the points, you will cry like anything. You will not understand. So this diagram is complex to understand, but the bucket diagram is easy to understand. Table, bucket is objects are stored. Interviewer surprised by listening that bucket diagram. And at last, like how I asked the 3 questions, actually here, this bucket diagram is a conceptual diagram. This will be implemented by hash table implemented by node array. Bucket is implemented by single linked list by using node objects. The bucket internally, the node object internally contains 4 properties: hash code, key, value, next. Okay. To find the bucket index number in the table, now the hash code of the key object is divided by the capacity. Default capacity is 16 divided by 16 and index number is found. And the original diagram is the next diagram explained. Tell me if you explain concept diagram and original diagram both with clear explanation and hash code equals method algorithm, any chance that interviewer will try to miss you? Interviewer will run behind you. Please come and join in my company, please. Practice. 0 location. If the remainder is 0, then in 0 location object is stored. 16 divided, the hash code number divided by 16 returns what? 0. For example, you are giving a object hash code number is 16. 16 divided by 16, 0. Then that object will go in 0 location. Null default in the hash code number is what? 0. 0 by 16 result is what? 0. then null will be stored in the 0 location. Okay, now? Understood? Okay. Amma? 97, 16, 1 kada? ఏం వస్తుంది 10 వస్తుంది 10 by 16 numerator is lesser than denominator 10 is will come na వస్తున్నా ఆ పాయింట్ కి వస్తుంది ఓకే నౌ టెల్ మీ నెక్స్ట్ వాట్ ఐఎమ్ రైటింగ్ hm dot put of double quotes a comma 3 ఇప్పుడు ఏం జరిగి చెప్పండి k3 dot hash code returns what 97 mod 16 equal to mod 16 equal to what value 1. Then tell me in a one index already bucket available na here this is called hash collision. Okay, when we are trying to store a new object with this new object hash code index number, if already object available, if already bucket available, now this object should go and store in the same bucket. That's what yesterday learned. Okay, now it will go into that bucket. Tell me, if it is going into that bucket, what happened? It should compare. Tell me, k3 dot hash code, what it will compare? K3 double equal to what is coming? K1, because the first object is K1. And tell me, reference is what? Same. What happened? True. True means stored or not stored? Not stored, comma, value is replaced. Your question I'll answer, okay? Let me complete this first. Value is replaced. Tell me, now this one replaced with what? 3. Okay, is it clear? Now tell me, if I write like this, what happened? hm dot put of, what do you write? Double quotes? No. Double quotes, no, 97 comma 4. Tell me what happened? Here, this is k4 dot hash code, k4 dot hash code, arrow, what is coming? 97 mod 16. What value? 1. Achha, hash collision again happened. When hash collision happened, what happened? This key is compared with the keys available in the bucket. And tell me, k4 double equal to k1 returns what? 97 reference and double quotes reference same? No, false. False means immediately it is added? No. Compare with what? Equals method. K4 dot equals of k1. Tell me, equals method first comparing type. Equals method overridden in the integer class, first compare with what? Type. Type is different, returns what? False. If both returns false, it is unique object. Unique object means should store in the same bucket. Right? That means new node is created. New node is created with reference what? 30. With what? Hash 97. Key. What is the key? 97. Value. What is the value? 4. And next value, null. And this node reference 30 will be stored in the previous node. Next. This is called linked list. Current node, new node is held by previous node. Previous node pointing to the next node. That is called single linked list. So if same hash code object is coming, because the index number will be the same, it is compared with the objects available in this bucket, means in this index location node keys. If all are not matching, then new node is created attached to the last node. That means it is storing in which order? In hash code insertion order. Hash code insertion order. When you are printing, it will retrieve the 0 index element, no elements. One index element, go here. First object, second object, third object. Then second index element, first object, second object, third object. third index element, first object, second object, third object. This is how the elements will be displayed. Okay, clear my point? If you remember, we have, when I'm adding the objects, double quotes A first stored, then double quotes B next stored, then 5 stored next. Remember? 5 hash code number 5 means less than 97. Na? That means it has to come to where? Before A. But it came before A na, after B na? After B. Why? Index number. Here hash code is not considered. What is considered? Index number. Double quotes, what do you call double quotes A index number? 97. 97 mod 16. What is the value? 1. That's why 1 index. That's why 9 A is coming first. Next, double quotes A, B by 16. Tell me, 16 index number is what? 2. 98 by 16, 2. That's why 2 index B is storing. 5 mod 16. What is the index number? 5. That's why in a fifth location node is created and 5 is stored here. That's why it's coming after that. Okay, na? Right. This is the how internally hash table is working. Hash table data structure is node array and bucket data structure is single linked list. Same hash code objects are stored in the one bucket in the one index number. Different hash code objects are stored in another bucket in another index number. Okay, na? Now, how the index number is found? By dividing hash code number object by the capacity. Now, tell me what is your question? If I store store over there. Okay, 1 minute. Understood your question. 10 by 3, how much? 10 by 3, how much? 3 point? You are mathematician. You are mathematician. That is a problem. It is Java. Think like a Java mathematician. Int plus int, result is int. Int minus int, result is int. Int into int, result is int. Int by int, result is int. Int means 3. What not? 3.333. 10 is what? Int. 3 is what? Int. Int by int what? Int. Then what is the value? 3, not 3.333. Okay, clear? So, index number weight is going third index. The object will go on storing third index. And tell me, what is your doubt? Any number? Tell some number. 16 by 3. Why you are taking 3? 3 by 16. Okay. 25 by 16. What is the value? It's not divided by, it is remainder. 25 remainder 16. It's not division. Quotient you should not take. Remainder you have to take. Chepenta. 25 remainder 16 is 9. 9? Okay, 9. It will go on stored in the 9th index. In 9th index, it will go on store. 4? Okay, 4. It will store in the 4th location. కన్ఫ్యూజన్ ఏముందా అన్న దాంట్లో? నీకు రిమైండర్ ఏమొచ్చిందో ఆ రిమైండర్ లొకేషన్లోకి వెళ్ళి ఆబ్జెక్ట్ స్టోర్ అవుతుంది అంతే. ఆల్రెడీ ఒక ఆబ్జెక్ట్ ఉందనుకో, తెలియనా? ఓకే, ఈ ఆబ్జెక్ట్ ఆల్రెడీ ఉన్న ఆబ్జెక్ట్స్తో కంపేర్ అయ్యి సేమ్ అయితే స్టోర్ అవ్వదు, సేమ్ కాకపోతే వెళ్ళి కూర్చోండి దాంట్లో. ఓకే, చూపిస్తాను. కోరుకున్నారు అర్థం. మన అల్గరిథం అదే వర్క్ అవుతా లేదా చేంజ్ అయితే చూద్దాం. ఏదమ్మా రిమైండర్ ఎప్పుడు 0-9 మధ్యలోనే వస్తా, ఎక్స్ట్రా రాదా? నాకు తెలియదు, అందుకు అడుగుతున్నా. I am not that much strong in math. That's why I choose Java. If I am very strong in maths, I would go Python. Reminder 9 కంటే పైన రాదా? నాకు తెలియదు, అందుకు అడుగుతున్నా. రియల్లీ తెలియదురా బాబు, నవ్వద్దు. మీకు కూడా రాదా? Girls, you know maths good? Don't ask her. Online students? Sir, if a hash code percentage 16 is greater than 16, then where it is stored? It never greater than 16. Find a case where you will get greater than 16. When you divide by 16, max you will get less than 16 only. 0 to 16 you will get. నాకు తెలియదు బాబు, నిజంగా చెప్తున్నా. I never work this much deep. Okay. Now look. I am taking as set of all types of objects. Okay, first system dot out dot println. Here I am writing what you call you written 9 0 by 0 remainder 16. How much? Control F11. 0 1 2 3 4 5 6 7 8 9 10. Okay, why? If a numerator is less than denominator, the numerator is the remainder. That is a simple mathematics shortcut formula. Okay, if I give some number 97, what is coming? 1. Babu, someone asked. Hemant, 197, 5. 13. Okay, na? Hemant. It's a large number. What is the number coming? 13. So if you divide a number, remainder will be less than that number. You will not get greater than that. Okay, doubt cleared? Now, in which location, in which index location this number will go on store? 13 index. Okay, na? Listen. If I go back to my program here, there is a question. If you remember, that day I have asked, what is that? What is the size? Up to how many objects I stored? 1, 2, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 9, 9, 10, 11, 12, 12 objects. What is the load factor of the hash map? 75. 16, 12, 75% means what? 12. When I store 13th object, its capacity is double. 16 double 32. That means all these objects are again divided by the latest capacity 32 and positions are changed. That is called rehashing. The hashing location. Previously, what is the location for the object? One location. Why? 6 mod by 16 is one location. Now, again, these objects are multiplied. I mean, division is changed by capacity what? 32. That's why positions are changed. Look, P equal to 13 position divided by 32 changed. Somewhere else it is going to inside. Here it is come. Okay, na? Now, let me ask a question. Tell me why hashing algorithm is given for increasing number of comparisons or decreasing number of comparisons? Decreasing number of comparisons. Observe, there is again Sun Microsystem has identified one problem in hashing algorithm. The problem is, this is my index number. Okay, suppose index number 1, in index number 1, bucket is created. Okay, in this bucket, now what happened? First node store, second node store, third node, fourth node, fifth node, sixth node, seventh node, eighth node, ninth node, 10th node, 11th node, 13th node. Okay. Then if I am storing new object, whose hash code index number become what? 1. Then this object has to compare with all objects available in this bucket. Na? Again, number of comparisons are increased. Again, first problem is coming back. What hashing telling? I will decrease number of comparisons. Again, what is the problem? Tumri fellow, if number of objects are increased in the bucket, again number of comparisons are increasing. Then how to solve this problem? Listen, they have created something called threshold. Hey, not Telangana state, threshold. Okay, threshold means cutting point. Okay, the measurement. Threshold equal to 8 means up to 8 objects, it will be single linked list. If you try to store 9th object, then the single linked list is changed as what? Tree. Do you know Robo 2.0? In Robo 2.0, that Pakshi become na. So tree, mobile become Pakshi, Pakshi become different thing, right? Like that. This single linked list become what? Binary tree. Okay, binary tree. Tell me, if you take a tree contains what? Roots, and contains what? Branch. Stem contains what? Branch. Again contains what? Branch. Again contains what? Branch. Now tell me, suppose this tree is having good number of fruits. Then one monkey wanted to eat that fruits. Then he is going entire tree na one branch. It started from the root stem. Then it is taking decision either go to left branch or go to what? Right branch, not entire tree. Tell me, number of comparisons are decreased or not? Previously, linear searching algorithm. Now it will go what? Binary search algorithm. Either it will go left side or right side. Based on the hash code number, it will rearrange that tree order. All small objects left side and greater objects what? Right side. It will do that arrangements background, and then finally number of comparisons are decreased. That means from Java 8 version onwards, initially the bucket is created by using single linked list. When threshold is greater than 8, when threshold is greater than 8, single linked list is changed to what? Binary tree for decreasing number of comparisons. So this is the all points about hash map internals. So now today, go to this second folder. Go to this first folder, map and hash map internals. Please read this notes. Hash map internals. Okay, all steps. Step 1, step 2, step 3, step 4, step 5, step 6. For storing, today I explain from step 7 onwards. For storing objects, hash map internal uses hash table data structure. The hash table data structure internal uses another data structure called bucket for storing same hash code objects as one group. The bucket is a collection of elements whose hash code is same. This bucket is also collection object. It is single linked list. From Java 1.8 version onwards, binary tree is also used. First linked list is created. If the number of entries in this bucket reach to 8 entries, means threshold equal to 8, then linked list is changed to binary tree for decreasing number of comparisons further. Bucket is used for storing same hash code objects as one group, so that comparing and searching will be fast, because currently adding entry key compared only with the keys hash code group of keys. A new bucket is created only for new hash code object. Then this object is added to this bucket directly without any comparison. If bucket is already available with this currently adding entry key hash code, the put method checks whether it's entry unique or duplicate by using double equal to operator and equals method. The hash table data structure is internally implemented by using node class array object node array. The bucket single linked list with a node class objects is created with the given entry, and its reference is stored in the table node array object in one of its locations. To find the location to store this entries node object inside put method, key object hash code is divided by the hash map capacity. For example, key dot hash code mod 16. This division's reminder value is nothing but the index number of the location for storing this entry. Check the attached diagram for understanding. This is the algorithm. This is the attached diagram, same execution flow, and this is the diagram. This is the conceptual diagram, and this is the actual implementation diagram, everything. Okay. Now today, I want you all spend the time for reading, understanding all points. Will you work out? So with this, we completed hash map internals. Okay. Tomorrow, we have to understand linked hash map, identity hash map, weak hash map. The next, enum map. Enum map. So tomorrow, Friday, and Saturday, Sunday, last class, present. Sorry, every Sunday you are saying last class. This Sunday compulsory. Okay. You are here for completing course or learning subject. When I am taking class, what is your problem? Full stack Java completed, core Java not completed, and then you have to blame me. Still you are running. Other courses are not at not troubling. Parallel you are attending other courses. So core Java not disturbing. Okay. 100% promising on you. Sunday is the last class. Okay, na? Sunday will complete, reset fully, and we'll close the batch. Thank you. That's all for today class. Let's not compromise with the collections framework, guys. That's why. And priority queue also there, I have to explain. Priority queue and array DQ. That's a topic we have to complete. Please try to spend the time on today algorithm with hash map internals complete document. Okay. I request you write down the notes. If you write notes, points will be registered in your brain. Thank you. See you tomorrow.